Well, how are you doing? How are you? This video is going to be about how the globe's claimed terrestrial refraction completely destroys um, their ability to get their latitude or any other use of the horizon to gain an angle to a celestial body. Not only do they have a curved surface, which makes the angle impossible and the dip correction impossible, but they also, because of their claim of a constant 7 over 6 and greater than 7 over 6, um, what they call standard and terrestrial refraction. The standard is the 7 over 6. The terrestrial refraction is anything greater than 7 over 6. That's the best way to understand it. Um, so, what they claim is basically an horizon that is never um, it's never horizontal with the water underneath the boat, right, with the use of a marine sextant. Um, and it is never in the same elevation in relation to the water underneath the boat. I'll show you what I mean in a minute. It's basically the horizon will be moving further away and getting closer, right, as it does in reality. But there's a big difference between what the globe claim, between the claim based on a globe and reality. As not only will their horizon be stretching further away from them and getting closer to them, as we see in reality, but their horizon will also be going down and up in relation to the water underneath the boat. So the dip to their horizon would be greater than any dip between the oil line and the water below the boat at all times. And this would be a consistently changing thing. So when they're trying to get their angle to Polaris, I'm going to use Polaris because it's the most easy one to use, then you could never trust the horizon because their angle to Polaris has to touch their geometric horizon. It can never be a refracted horizon because the latitude and longitude grid governs why the globe has to have an exact 3958.09 radius. It's because they have to match if you they have to match the latitude and longitude grid, right? This is what they have to do mathematically. So if they're using a refracted horizon, even a 7 over 6 means they're using an effective radius of 4,618.83 miles, which means that their horizon will not be in the position it would need to be for them to ever try and get their latitude. And even if the horizon, even if they didn't have 7 over 6 and standard or terrestrial refraction, even if that wasn't there, they still couldn't do it because they can't do dip correction. Can't be done. The dip correction doesn't work on their model because their model, not only do they have a curved surface, which makes it impossible, but the height of the eye above the surface of the water below will always be less than the dip they would have between the eye and their horizon, because their horizon, no matter whether they're talking about a refracted one or their actual geometric horizon, would always be below the elevation of the water underneath the boat. So it can never work. But anyway, I'll just show here, right? So this first circle here, that is a 3959 radius, right? Let's come out of it. The second one, sorry, the second one here, right, which is kind of orange, that is the 7 over 6, right? 7 over 6 radius. So that's the size the globe goes from this blue circle to this orange circle. The next one is 8 with the red is 8 over 6, right? Or so now that's the size of our globe. The next one is 9 over 6, which is the green circle, right? That's the size of our globe. And the last one then is I put in is 10 over 6, or the second last one I should say is 10 over 6. And that is the size of our globe. But what this means is all these little sections here. So if we use just the 7 over 6 orange circle here, right, this little section here between E and F, right, that much of their globe will be missing. Not missing, but of the circle will be a non-circle. So what they basically have, if we just track from E right around to F, what they have is an arc length of a circle. So this is a consistency. On their globe, they say there's a consistency of at least 7 over 6. That means the globe is never a circle and it's always an arc length. Right? Now, there's other problems with that, right? I won't go into now, right? but that is a big problem for other reasons. But it doesn't matter. Right now, we'll just stick to this. So their globe is always at this orange arc length. That's what it always is, right? It's never less than 7/6. That's what they say. There's always at least standard 7/6 or refraction, right? When it stretches to 8/6, then you have this much, right, of an arc length is gone from that circle. So that means then if we track from G around to H, that is the full globe. This part here doesn't exist. It's a ghost length. Let's say a ghost arc, right? So this is the ghost arc, I'll call it for the purpose of this explanation. This is the ghost arc for 7/6. This is the ghost arc for 8/6. This one here is the ghost arc for 9/6, and this one here is the ghost arc for 10/6. And it goes on and on and on. So what basically happens is that they start off with this orange arc length here, and that becomes a different degree of arc length with the red one, and then a different one again with the green one, and a different one again with the purple one. So it's what happens is you're just taking the distance around this circle here, and you're placing it on, let's just say, the purple circle here. But it only stretches with the purple circle. It'll only stretch from K around to where L is. It won't be able to obviously stretch this far because it doesn't have the length. So this is how they work it. So what they do is this changes the position of the horizon, and that way they can at will, and no matter what observation, no matter how far away the horizon is, they can start claiming, oh, it's just terrestrial refraction. Nonsense, right? Forgetting that is not only does that debunk globe, because you need to have a measured R value off of a physical globe to even make the claim of 7 over or greater than 7/6 R for R value. But you also have the problem that the horizon is within that claim, and all globe claims must be below the water underneath the boat. You will never ever, no matter how much refraction over 6R you will ever have, you will never have a situation, well, depends, mathematically maybe you could have a situation where your whole globe is not an arc length anymore, it's just a horizontal line, because that's the way they have to go. This is what they have to do with it, right? So all their claim means is that they claim whatever amount of over 6R they need to claim depending on the observation. And what that means is just a changing of a ghost arc. That's all that is, right? Because their globe, remember, as I said earlier, is never less than 7/6R. This is what they claim, right? So that means they never have an actual physical globe to show you. They only have mathematically an arc length is what they are trying to claim. Now, we don't live on an arc length. That's just idiotic and stupid. That's worse than saying we live on a globe, is to say we experience an arc length. We don't experience an arc length, we experience a horizontal plane, right? But just to show the ridiculousness of this claim, right? I'm just going to, right, go here a sec, get this, bring up that a bit, right, so we can see it, right? So for the black swan image, just the basic one that we use as an example. It's just an example, right? No need, right? Because it's a great example. Shows the horizon past the two, at least, we say 10 miles, could be more, could be 15 miles. We don't know how far away the horizon is because it's not a physical location. How do you measure it? But it's definitely behind the two oil rigs from a 1 foot observation from the beach in Santa Barbara. So if we were to use the black swan image, right, that we use as the example for that argument, then this would be the size of this would be the size of a circle they need to claim, right, mathematically. But this little thing here, if we just move in, this would be their globe, right? That's just for the 10-mile horizon. If we look at the more recent observation done by BLMS B69, where he could see an horizon at 1 foot 30 miles away, right? But that was at a point that was 30 miles away. He had a piece of land that was 30 miles away. I think it was an island, 30 miles away. So from a 1 foot observation. So that would mean that that circle that they'd have to create then would be way huger than this. So that's all this from M right around the C is a ghost arc length. That's what it is. Because, and this is what they needed to claim that the globe Earth became due to refraction, right? In just that image, just the 10-mile image, never mind the 30-mile image. And then you have the ones done and done by Dr. John Dee. Like, I mean, what's that going to be? That's going to be a ridiculous, huge ghost arc again. You know, this is complete and utter nonsense, but this is what they need to claim. But what you will even notice here is this is something that's important. If we take C here, right, and M, even under those conditions, a person standing on C, right, if you were the person standing, let's say just say where C is and where M is, you can see that M is lower in elevation. If you had a boat right here, then where M is would be lower in elevation. So even under those crazy conditions, you still don't have a horizontal. Now, this between C and M is basically the whole of the globe Earth, right? So between C and M is 24,856 or 65. I'm not sure where it is. The length of two, basically the length of two corresponding. I'll get it now. Let's get it right. Right. So 6,213. I think it is 213. Let me see. Multiplied by 2. Right. Multiplied by 2. 24,852. Right. That's what it says here. It might be a couple of miles in or out. 24,852. So what that means is that between M and C, this is during the Black Swan photo example, that is 24,852 miles or 56, whichever, between those 2 points, right? But you still have to remember, there's still, right, if you bring a horizontal line out here from C, it'll still go over the top of M, right? So that means they still, even under those conditions, the horizon is still lower than the water underneath the boat. So if there was a boat here, the horizon out from that boat, it's still slightly lower, even under those conditions, right? Because to come up with, they can basically, if they keep on doing this, they can never even come up with a horizontal, because no matter how big you make the circle, it's still going to be a circle. You can't have a horizontal on a circle. So no matter what you do, it's always going to be a circle. So you have this big ghost arc length here, and this little arc length in here is the globe Earth. That's what it is. So, so to explain it differently, right? Sorry. So I'll go into here, right? So let's just say, let's make this a bit bigger, right? So let's just say that is, right, the sun or whatever on the globe, right? Doesn't matter. Or the Polaris, let's just say. We're going to use Polaris. And let's just say this is somebody's angle to a geometrical horizon, the globe's geometric horizon, right? Now, even at that, right, they would have to come down, do the dip correction down to get the horizontal, to get the correct, right, the correct latitude. They'd have to do that, right? But they can't do that on a globe, right? Because, right, I just show here, can't do that because this is, right, the next thing we must account for is the fact that the horizon we see is not really 90 degrees from our zenith or from the vertical, unless our eye is right at sea level. At sea level, the horizon is tangent to the sea surface and at right angles to the vertical. That means that, well, he's basically, they're using the word tangent. Nobody uses the word tangent in there because there's no tangent possible. Because you have the water underneath your boat, right? I say, unless your eye is right at sea level, right? That means the water underneath your boat, right? Your eye is on that water, and that's in a direct horizontal with the horizon, which is at 90 degrees, right? They need 90 degrees. So the next thing we must account for is the fact that the horizon we see is not really 90 degrees from our zenith or from the vertical, unless our eye is right at sea level. At sea level, the horizon is tangent to the sea surface and at right angles to the vertical. That means the water, your zenith is coming down through your head to the water underneath your boat and then making a 90-degree right angle horizontal line straight out to the horizon, and through and past that point to the GP point. That's what it's doing, right? The use of the tangent in here is just due to the person writing this not being able to correspond reality with their belief. They have a globe belief, but reality gets in the way of it. So that's why it's contradictory. You can't have a tangent. It doesn't work that way. You can't you can't claim even a tangent for the globe because you need to use the reality. You need to use the physical earth. That's what you're using: the water underneath the boat and the horizon. That's not going to be a tangent. That's going to be a horizontal line. But it doesn't matter because within this here, it's admitted that at sea level, the horizon's tangent to the sea surface and at right angles to the vertical. Right? So claiming a tangent is pointless even if you are a glober, because for a start, you're claiming that you're admitting that this process can't take place on a curved surface, if that's what you're claiming. If you're claiming a tangent, you're admitting that it can't be done on the surface of your globe. That means it's not being done in reality on a globe. End of story. But secondly, you can't claim a tangent anyway because you need to use the actual surface of the water, right between the boat, the water underneath the boat, and the Jeep and the horizon and GP. You have to use sea level, actually sea level. It says here at sea level. You're using that to get 90. You can't have a 90 if your horizon is lower than the water underneath your boat. Can't be done. So back to this, we have here. So you can't do dip correction on the globe because the dip is bringing the eye line down, right? So no matter what you do on the globe, this 0, let's say P is your eye and 0 is the horizon. No matter what you do, if you bring this down, right, and trying to correct for a dip, your height above the water, right, you might have a 34, let's say it says here 34.8, right? But that's still not going to be a 90 because that's your vertical. If I put in a, see if I can just, 1 second, right, I'll put a vertical in here, whatever, right? It's not going to be perfect. Let's get the show grid, major minor lines, just 1 second, right? Get rid of that grid again. Show grid, no grid, right? So there's your vertical, right? There's your vertical here, right? And there's your zenith, right? This is your line to the horizon, right? And after you've done dip correction, you do that's not 90. That's not a 90 degrees. I'll prove it, right? Where are we? I shouldn't have to prove it, but you know, if I don't do this kind of stuff, you know, people are going to come up with nonsense. So 1, 2, 3. Take this. Sorry. Move this over. Get rid of that. Take this. Up. Change the angle to 180. Pull this out. Get rid of that nonsense that I don't need. Now, so right, as you can see, right, this means that this here, right, if you do dip correction, no matter what you do, you'll never have it exactly at 90. Now I know it's going to be a smaller correction than that, but the point is that you will never have a 90. You can't have a 90 on the globe. So even using the globe's geometric horizon, you can't do dip correction. So you'll never be able to get your correct latitude. Your latitude will never be correct. Now, I made videos on this in the past, but I have no choice but to make another one because people are just not listening. Right? People just don't be listening. And they keep on asking the same thing you've answered in the past because they don't listen in the first place. Sorry, I meant to do that one. Right? So let's just say you have a refracted horizon then. So we don't have the geometric horizon. So the closest you'll get to your latitude on the globe, right? Besides the fact that this line would have to be curved on a globe, I don't know how that's going to work, right? But hypothetically, if we go into fantasy conceptual land, right, what we can say is that the best you would do is you would bring this line down to the sea underneath underneath the boat, and then at that point, that's not going to be a straight line, right? Not only is it not going to be a straight line, but because you now have a curved surface, but more than that, the water underneath the boat is still above the horizon, so that doesn't work. So you'd have to always not have dip correction. So that would be the closest you would get. This type of a thing here would be the closest you would get to any kind of an angle for a latitude, and that would still be out because you can't do dip correction, because the dip correction is going to be this line back to here and that height above the sea, right? But you can't do that because your sea surface on the globe is going to be higher in elevation than the sea surface of where your horizon is. So that destroys it. But they don't claim there's a geometric horizon. They claim the horizon is refracted, which means that the horizon will be slightly further away from you, right? This is what they claim, right? But the problem with that is this, right? I'll just show this. The problem with that is this, right? It changes from 7 over 6 r, because at a baseline, to all kinds of things. So it's going up and down and up and down, and it's going further and closer and up and down. But you never, if you look at the black here, this one here, look at this one, right? You never have, you'll never have a 90. It'll never work. So when you have, let's just say this is, you have this where you have 31 degrees, you can't do dip correction, remember, and you have a 31-degree angle to Polaris, let's say, right? Then you're using a situation where your angle will never match the latitude, which would make latitude impossible. You'd never be able to even get latitude. You'd never be able to come up with latitudes on the globe. If we lived on a globe, latitudes wouldn't exist. You couldn't have latitudes and longitude. Maybe longitudes, but not latitudes. You couldn't have them because you could never use them, because they have to come from Polaris. That's where they come from. All the latitudes come from Polaris. That's where they all started with. So you probably wouldn't even come up with longitude lines, but latitude lines, you can forget about it. Because if you have an horizon that's doing this all the time, right, it's getting closer and further, but it's going up and down, and it's always below the sea level underneath the water underneath the boat. So if it's always doing this, right, this is your angle to Polaris, 32.7, right, but your real angle to Polaris to get the correct latitude is actually 34.7. Then straight away you have your wrong latitude. Your latitude is wrong straight away. And but it can never be right because of standard refraction, because it will always not be touching the surface of the globe. Let's say that's the surface of the globe. Standard refraction puts it here, and that's a basic constant. So it's never not refracted, which means that it's not geometric, which means that it's not a globe. But the point is, within their claim, it's never not refracted. So consequently, you could never get your correct latitude because you're using a refracted horizon. And you take an angle to that horizon now, and you get 36.7 when it should be 30. Let's say when it should be at 37, right, degree angle. But when you have 7 over 6 r, it's 35.6, right? So instead of it being 30, let's say 38, let's say instead of it being 37, right, as it would be to a geometric horizon, because you always have a constant of 7 over 6 r and greater, it's 34.7, right? So that's the wrong angle to the latitude, because the latitudes don't work on a refracted globe. They can only work mathematically, don't work in reality. Only mathematically can they work on an actual physical globe with a geometric horizon. And if you always have a refracted horizon, right, always, that's at least 7 over 6, right, then what are you going to do when it's greater than 7 over 6? So if you take an angle now, right, not only would your angle be wrong, right, because you're using, not only will your angle be wrong because you're using the refracted horizon and you can't do dip correction, but if you take an angle an hour later where the weather changes, your angle could be that. So you never have a consistent angle. So right now it's 34.2, then in an hour's time it's 33.3. Because your horizon is not just moving further, it's not just going further and closer, It's also, as it goes further, it's rising up. As it comes closer, it's going down. It's not just out, in, out, in. It's going out and up. I say out and up, and it's going back and down, out and up, back and down. Not just out further and then back in, because like it does in reality, where the water underneath the boat is always in a horizontal with the horizon and with the GP underneath the celestial body. In reality, that's what happens. But on the globe, you see this black box here, it says 90, you can never have that. It's always going to be a consistently changing thing. So if you're anchored somewhere and you take an angle to Polaris, let's just say now, no, you have a refracted horizon, right? And you can't do dip correction. So straight away it's wrong. But in an hour's time, it might even be more wrong, right? An hour's time could be 29 as opposed to 33, let's say, whatever. So the point is that you will never, ever, ever have your correct you'll never be able to even come up with latitudes. You couldn't come up with them because the horizon is not in a consistent position in relation to the water underneath the boat. It's always rising and lowering in elevation in comparison to that water, and it's never, never 90. It's never 90 like it has to be in reality, right? So, just to give a final on this, right? Here we have, right? This is what will be happening. This is reality. This is a real horizon. Well, it's not. It's a diagram, but it's depicting a horizontal here horizon. Now, on the globe, with a geometric horizon, that horizon has to be probably here. With 7/6, it's about here, and greater than 7/6 going up and down, getting closer and moving further away, going up and down, up and down. It's never here like it needs to be to get to 90. It's always going down, up, and it's in its geometric position, ever, on the globe. So it's always at least here, and it's always going up and down, up and down, up and down. You could never use that horizon to get any kind of consistent angle to any celestial body. Which means you could never, and I mean never, never come up with the latitude and longitude grid. If you're relying on latitude lines to help you with the longitude, you can never do it. Longitude lines, possibly. Latitude lines, forget about it, because you'd never be able to use them in the first place, which is the way they were originally used, which is by sailors. They can't do it because their angles would never match what they need to be. So you think you're at 45 degrees latitude because of the horizon being here, and you're anchored, and an hour later you think you're at 52 degrees latitude. Do you mean what? Like 45, 52, 21, 38. You never know where you are. It's a joke, right? It's a joke. The globe is a joke, total joke, and this one stupid little thing here, right, debunks it completely. So I'm not going to keep it going. Been going long enough. I think that's basically you've all gotten enough out of that, and I'm sure anyone who watches this will either have a problem with me instead of addressing reality, or they will come up with stupid rebuttals to it that aren't rebuttals, or they actually will accept reality. One or the other. Thanks for watching.